That's like, I will.
Yeah, that should be.
Perfect. Oh, they can see that. But that's fine. Sure. What? Like, oh, I would love for you to get started, but I think I should do it because I should get used to it.
Yes, you should.
Okay. Okay, everybody, we're gonna start now since it's 3:40. Today we're doing a curve fitting discussion. I wasn't here for when you guys did curve fitting, but I assume you guys did it already. So, or at least learned a little bit about it. And we're gonna go a little more in depth with it today. So if I can have everyone go to B courses and go into files and then go inside the discussions folder and download today's discussion. It should be labeled in another folder called curve fitting discussion. And in there should be an sort of empty Jupyter notebook and a CSV file full of data. So I'll give everyone a couple minutes to get that downloaded. And once you have it downloaded, you're welcome to start. So yeah, if you have any trouble with getting it downloaded or anything, just let us know. Yes, exactly. Yes, so we can.
It's in the discussions folder.
Yes, and we're gonna walk through that today. Good. Fair.
It's that time of the semester. It's the evening.
3 hours and 3 hours is low for me.
That's too low. That is in fact too low for anybody.
Yes.
4 is like, I'm okay. 3 is.
That's insane. I can't go below 7.
Me either.
I cannot.
Yeah, I can't function.
I've tried so hard.
And that's so fun. Like that's like on the level of like, it's like sleeper agent, like brainwash, like you hear the trigger words, it's like you have to continue it.
Songs. There's a bunch of songs like that. I can't think of any of those. It's back now. All-Star Basket. There's a few trigger words there.
Oh yeah, definitely.
If anyone says look at this photograph, it will
Yes.
go directly at
Yes.
the back. But like I don't remember the original version, I remember a cover of it. It's like
Look at this graph. I know the graph one. Okay, I assume everyone has gotten the file downloaded, so I'm gonna go ahead and give you guys a brief overview of what we're gonna be doing. So, basically, we're going to be curve fitting some data from NOAA. I believe it's a department that does like atmospheric science and ocean science, and it's just methane readings, so not super important. We're just really focused on the actual curve fitting skills today. Yeah, but methane's boring. So, anyways, so I'm gonna give you guys a couple minutes to go through part one. Um, if you don't remember, try looking back at your previous notes first, before you raise your hand and ask a question, because we have done this before and you guys know how to do this, and I know you guys know how to do this. Um, but yeah, so go ahead and get started on part one, importing the data, and we'll come back in like 5-ish minutes or so. Yeah.
To answer questions for the first time.
Yes, you can say that.
We're not going to answer questions for the first 5 minutes, so if you want help, you can talk to each other. You are allowed. And then also, if you don't want to just be recording blank space, you hit pause recording.
Oh.
What I like to do if I pause a recording is like, anyone who's looking, who's watching on this, anyone who's watching from home, please take, or pause the video, take a second.
Okay, I will do that. And then for the people watching the recording, just take a second to go through part one of this discussion notebook. Thank you. Yes. Yes. Yes.
So that online recordings and everything. I love you.
Oh, are you gonna like? Are you? Oh, sorry. Like edit them?
You're gonna like make a whole course online. Yes, that's the question. Let me know if you need help. I will. I really love that. I will need so much help.
I was gonna sell access to it on the internet.
No,
$10
it'll just be on
price.
YouTube, right? It's just gonna be on YouTube.
Hopefully, yeah.
Basically.
Well, I mean, we'll see.
Okay.
It might be. I might have it as like a limited access thing so that. Cause I wanna collect demographics on who needs our course.
That's good.
$10.
So it might be like a fill out a Google form,
Oh.
part of the application type. People who don't get it still get access. Yeah,
I like that.
and so that we can show the school and be like, look who needs this. It's not just extra people.
Yeah.
No. I mean, yeah. The applications for the class are many, I don't know, have you looked at all of the majors that apply?
No, but I know it's like all of them,
It's all,
like basically every STEM major.
yeah, the humanities are less well represented, but they're still there.
Really?
Okay. Art, English.
The creeper logo? Oh, I actually have no idea. Is that Mine? It is Minecraft. Yeah, I haven't played in ages. It's just there.
That's so funny.
Yeah, there's a lot of unused apps here. Yeah, I also have Roblox down here. I have Roblox. I haven't played that in ages either.
The thing to the right of Roblox.
This is Astro Image J.
Oh,
It's an image processing software for images. Yeah.
That's sick.
Yeah. Yeah, I have a lot of stuff on here.
Is that Valerie?
Is it Valorant? No, I don't play Valorant. Where? Oh, this is Civilization 5. This is the best Civilization game, objectively. There's a new one that came out just recently. I think so.
he got like 50% positive on Steam.
I don't care. 5 is better anyway. 5 is better. I don't care.
Analysis?
Like,
It's like platform map on.
oh, 104? I don't know if it's 104. I've heard bad things about it.
I think that is one of the, I've also heard bad things about it. But I know people who think in
like the assignment I gotta do with my grade class this week, it seems like I'm about to have to learn analysis to figure out how to do a complex contour integral. Cause normally that's like you learn it.
Do with like math 53. Right?
Integrals are part of analysis.
Contour integrals. I mean, integrals are multidimensional calculus. That's multivariable calculus.
Wrong,
And that's 53.
wrong word, path integral.
Path integral.
Yeah.
Okay, well.
Oh,
Okay, everyone, we're gonna come back together. So did anyone have any issues with this first part? Yes.
It told me error tokenizing data, see error, expected one field in line 8, saw 2. Same here.
Okay. Let's see. Wait, I'm gonna walk over and you have the same problem? Did anyone else have that issue or okay. Okay. Let's see. Okay.
And this is a part of analyzing this data.
Okay. What happened?
Yep.
Oh.
Can you pull up the?
Oh, yes. Okay.
Yeah.
Oh,
Yeah,
yes.
you know it.
Yes.
You know it.
I know it's not. Okay. So if we actually open up the CSV file, you guys see a bunch of lines of just stuff. You know, it's like describing what the data set is, etc. But once we get to line 46, that's when the real data starts. So that's why pd.read CSV has no idea what is going on because there's a bunch of these hashtags and comments that doesn't know how to deal with. So I gave you guys a little hint. Here it says there's an argument in pd.read CSV called skip rows, where you can skip a specified number of rows that are that like you can say like, oh, I don't want to include these rows in my eventual data set. So the way we deal with that is by calling pd.read CSV, and then the name of the file I think is whatever this is, ch4 and mean gl.csv. Yes, what's up?
Did anyone solve this
Oh,
issue
yeah.
themselves using the hint? What did you put? Equals 47? Cool.
Very
Why
nice.
47? Just out of curiosity.
Yeah, why did you do that?
Great, okay.
Perfect. Yeah, and I think it has something to do with indexing why 46 didn't work, because this is line 1, but I guess like Python reads it as line 0, so that's probably why it didn't work. But yeah, good job. So yes, we'll do what you said. Skip rows equals 47. And oh wait, hold on, I didn't import this.
Always run your
Yeah.
imports, guys.
I frequently forget that. And look, we have nice data.
Anyone notice an issue?
Like, doesn't include the first line for some reason. It was so
Oh,
that titles.
Yeah, it doesn't.
Do you guys see
Yeah.
where the titles
Oh.
for each data column are?
Line 24.
They're at line 24. Okay.
Yeah. So what should be our skip rows statement instead? 43. Let's try it. Perfect. Good job. So now we have nice data with headers, as I conveniently forgot. So yeah, so just based off of these column headers, what do you think this data is? I'm taking answers, by the way.
We're better at awkward silences than you guys, so. We'll wait.
Methane production and some uncertainty in that production.
Very nice. Yes. I assume, well, what can you point to me which ones like are specifically like what is the uncertainty? What is the
Oh, uncertainty is the third column.
yes.
And the mean would probably just be mean.
Yeah,
production.
exactly. Anyone else? Anything else? Yeah, I thought UNC. I didn't know what UNC was. I was very confused because my first thought was like uncle, but I don't
It's
know.
also mine. And we were puzzling over it.
Yeah. So, and then what's the other column? Can someone tell me what the other column is? Yeah, exactly. It's pretty straightforward, I think. So, yeah, starting at 1984 all the way to 2023, so it's pretty recent. So, now that we have part two, or not, sorry, part one finished, we have our data loaded in. I'm gonna give you guys some time to work on part two, where you're just gonna plot the data based off of the table we just created. So I'll give you like 5-ish minutes for that.
Bonus points if you get the error bars.
Oh, yeah.
Do you have a timer going or should I?
Yeah, can you get one going?
As before, for those of you watching on the recording, feel free to stop the video and try it yourself. Okay, back all together. How are we feeling about plotting? Raise your hand if you've got a plot. That is a lot of plots. Very nice. I like lots of plots. Yeah, so I'm gonna let you guys kind of take the reins here. What are you doing? What's the first line?
PLT dot figure.
PLT dot figure. Parentheses. I love Jupyter Notebooks. I love that it opens and closes the parentheses for me. I hate typing, so maybe I shouldn't be a coder, but that's okay. What's next? What are we doing?
PLT dot scatter.
PLT dot scatter. What are we scattering? What's our X data? Let's scroll back up here. What's our X data? Thumbs up, middle down, year. Like it. I also think it's year. How do we call the year? Do we need to assign this read CSV to something? Okay, I'm gonna call it data because I'm original. Data equals, and then I'm also going to do display data. This is just a fancy way of making it look pretty. Because if you just called data, actually, it may actually do it anyways. Yeah, it does. But if you print data, then it looks ugly. Yeah, that looks bad. I don't like that. So we're gonna display it. That looks nice. I like that. Okay, so what's our X data again? How do we call that? If our variable that holds our data is called data. Yeah. I see a hand. Here.
About mine didn't assign mine to a variable,
Uh-huh.
but I did that that exact form except I have df here and it still works.
So you just said pd.read CSV. Let me restart the kernel because this is very interesting because I don't know. I've never seen that. Okay, it doesn't like it here. Did you just have it df of year? That is probably it. The Jupyter Notebook remembers everything. That would have been sick though. I would love it if calling pd.read gave you a just automatically assigned to a df, but there would obviously be issues with that.
Cool. So plt.scatter of data year. And then what's our y data? Mean. Thumbs up, middle down on mean. Yay. So I'm just gonna use the same. And then are we gonna give it a cute little color? We're gonna give it a cute little line style. We're gonna make it look nice. Yes, we are. Sucks. I like color equals black. It's a nice little foundation. Then line style. Oh no, we don't want to do scatter. We don't want to do line style with scatter. That is not good. Because I think it's marker. Or give it just an O. Anything else I should do? Good practice. Maybe some labels. Yeah, let's give it some labels. plt.x label. I spell good. And that's year. plt.y label. And that's mean CF4. That's what it is, right? CH4. Thank you. Yes. I think it's the chemical compound. And then what's the last line that we run?
plt.show.
Slay. If you run it without plt.show, it'll show it. I highly recommend plt.show. It's just cleaner. Yay! Okay, that's cute. That's really cute. I also like grids. So plt.grid gives it grids. I like grids. It's very cute. Cool. What's next? Next up is curve fitting. Yes.
Is there a way to access our data without using like the title names, but instead like indices? Because I couldn't get iLock to work with it.
I feel like, Let's find out. So what were you typing in for iLock?
I pretty much just had what you had, but .iLock instead of year had year as well.
Data.iLock of 0, like this.
Right. Oh, that's
You need like you want to tell it you want it.
This, okay, so I think iLock. So this says I want all of it. I think maybe, haha. So if you do data.iLock, the first index is your X value. So if you do just data.iLock of 0, it'll give you the first row. But then if you do colon comma 0, this is it's a similar notation to this, but it doesn't like this. So you have to do this for iLock. And then another thing you'll have to do, I think, is dot values. And then that gives you an array of values. You don't actually have to do that for plotting. Does anyone have, do you want me to do what function? Does anyone have an idea of what function this looks like? Because what are we doing when we're curve fitting? We're saying, okay, my data kind of looks like this mathematical model. How good does my model actually fit my data? So what model does this kind of look like? Do you remember our math functions?
kind of looks like X cubed.
I like cubic. Any other ideas? Do we all like cubic? Thumbs up, middle down. Big slay. I also like cubic. So your next job then is to choose the model. If you don't like, oh my God, it's awful. If you don't like cubic, you don't have to do cubic, but make your function. And then do your best to implement scipy.optimize.curvefit. So first, make a function that returns a cubic fit or whatever model you want, and then try to implement curvefit. Cool. 5-10 minutes?
Yeah.
Okay. And then for those of you watching, again, just take a second to walk through this by yourselves.
Okay, any other issues that people ran into, want to share? Okay, if it did work for you, what function did you use? Yes.
I use depth of X and then A, B, C, D.
X, O, B,
The
Yep,
function, and then it returns, and then you put in a cubic function with all those.
yeah,
A has cube and then on.
yeah. It's like AX cubed, right?
Yeah.
Like A times like this X cubed
Yeah.
plus B times X squared, I believe, right? Right?
Yeah.
Okay. Plus C times X, or I don't know, in there, plus D. Perfect. Okay. So yeah, Jordan, that's probably why yours got a little funky, because slightly off with the def, but that's okay. That's okay. We ball regardless. Okay, so can someone tell me what the next step is after we make a function to fit our model to? Do we know what to do? Plot it. Yes, you can plot it, but right now it's just a function. It doesn't have any input or output or anything. So we have to do the curve fitting part first before we can plot it. But if we want to curve fit something, what do we need first?
Initial guess.
Yes, exactly. We need initial guesses. So, Deacon, what did you use for your initial guesses?
Right, I had like P0 equals 1, 1, 1.
Perfect. 1, 1, 1. Perfect. So yeah, as our initial guesses, we have to give it initial guesses. Otherwise, it doesn't know where to start and it gets mad. Because it's a polynomial function and it's pretty simple, you don't really need any super complex guesses or anything. So that's why 1 is fine. Oh, do we need 1 or 3 or 4? Forget. Is it 4? Oh yeah, it is 4. Yes, you're correct. We have 4 parameters. Yes. Okay.
Does it make sense
Yeah.
Why I was quibbling about the length of the initial guesses. Okay, length.
Cool. Okay. So, and then what's the next step after so we have our initial guesses, right? How do we actually use curve fit? Can anyone say for me?
Fit.curve.
Yes, fit.curve fit. What are going to be our arguments? Someone new, please.
You're also allowed to look up the documentation.
Yeah. You also look at your notes too, if you guys took notes. Or not notes, but like, you know what I mean. Okay. Okay, so what we do with fit.curvefit is we pass in our function that we made. So we call it f. You can call it whatever you want though, but we call it f, so we're gonna use f. And then we also have to pass in our x values. So if you guys remember from the plot, our x values are data bracket year. So those are all x values. And we also have to get our y values, which is over here data mean. And then the last argument is our initial guesses. So we made a list of our initial guesses called P0. And that's the last argument for fit.curvefit. And if you guys remember from last time, fit.curvefit gives us 2 values. One is a list of the fitted parameters. So we're going to call those params, I guess. And then the other value is the covariance matrix. Don't ask me what that is, but it's something that gets spit out. So we do that. I'm sorry, I didn't run this. Okay, there we go. So now if you look at our parameters, these are our fitted parameters for this data. So graciously given to us by SciPy. And our covariance, once again, I don't know what that is, so don't ask me. But yeah. So the last thing, well, I guess last thing, because we have like 6 minutes left. So we're gonna do is we're gonna calculate chi-squared, the chi-squared test statistic. Yeah, that's what I was gonna do. Yeah. So chi-squared is a test statistic. It's been a while since I took AP Stats, so I sort of forgot what it does, but this is the equation for it. And the great thing is we can put that into Python. So it looks kind of scary. You see there's like a sigma here, it's another baby sigma here. This means that this is the error squared. So the error is given to us by the table. So the error, if you guys remember, is the unc. Yeah, the uncle. The y expected is what the function that we, or the model tells us what should be happening at each x data point. And the y measured is what the actual y values are. So the y values are all here, as you guys can see, I hope. Yeah. And then all of these is added together, and then it's not square rooted. Okay. But yeah, so the first thing we're going to do is we're going to look at this middle part right here, which is the y measured minus y expected. Can someone tell me what our y measured is? Again, I just told you, but can someone tell me? Please. Yes.
For me,
Yes. So data mean is our y value. And then how do we get our y expected value? Can anyone tell me? Anyone different?
That was Y estimate, that was a Y estimate.
Y estimate, yes. So how do we get that? Like,
I think, yeah, we just call it YS.
call plot S. What?
New solver thing, or is it part of it?
The function?
Yeah.
Oh yeah, call the function. Yes. Yeah, exactly. Yeah, we call the function. So it's gonna give us, so our function takes in a bunch of arguments. Our x data. So if you guys remember, x data is data, I think it's data year. And then it takes in A, B, C, and D, and SciPy gave us its estimates for A, B, C, and D. So we're gonna call him params 0 because that's the first element of our parameters list. And then params 1, params 2, and params 3. You know what? It's probably way easier to read if we put this into a variable name. So we'll call this like y expected. Will be this, so that it's not a super long, unreadable line of code. So if we do that, this gives us a list of all of our expected y values. So yeah. So that's our y expected. And then what do we want to do with the difference between our measured and expected? Any takers? Just this part right here. I saw you mouth it. Yes, we want to square it. Perfect. Good job. So yeah, we're gonna take this whole value and then we're gonna square it. And then we also want to take this and divide by what? Anybody? Yes.
uncle.
Uncle. Yes, we want to take our uncle and divide by it. So uncle, I think is data unc. And then we want to square this. So I'm just gonna make parentheses. Yeah, that should be fine. Okay, and then finally, what's the last thing we want to do? What do we want to do with all of these, with all of this part? What is this symbol right here? What time is it? 4:28. We have 2 minutes. Anybody? Anybody, please. Yes, exactly. We want to sum the whole thing. So we can just call sum. And this is that looks very high. I may have done something wrong, but did I do something wrong?
Everything's like squared on both sides.
Oh, let's see. Hold on. Did I do something? Is it fine? Okay, that's very high. I don't know why it's that high, but yeah.
You can tell if it's too high. if
Yeah.
you Take the reduced chi-square.
Yeah, okay, sure. We can do reduced chi-square too. Reduced chi-square, is it error minus I don't remember what it is.
Divide out the,
By the
degrees of
number
freedom outside of the sum,
outside of the sum. So like
so outside.
oh right here like this, like this. Okay, and then we divide by 4. Wait, it's 4. Length. So we're saying like the length of theta on the excuse me, minus 4. Okay. Ah, that looks nicer. I guess. No?
No.
Oh, no, it's not. Okay. Yeah, I don't know how to read it. Oh, okay. Well, anyways, it's 4:30, so you guys are free to go. Hopefully that was helpful. Yeah, go to her office hours. Yeah. Thanks for coming.
Yeah, good job, guys.
Yeah, it's probably just an error with how I did this. Yeah, this is disgusting. Yeah, I think is it this parentheses?
Potentially.
Because, oh,
You have to,
I squared that, right? And then this is divided by
I wonder if it's trying to divide the exponent.
divide the exponent. So like put parentheses here.
Mhm.
That's okay, it's still the same.
Yeah.
Okay. We'll
It's weird.
we'll figure it out and post the solutions later.
Yeah.
Okay. Oh yeah, the solutions will be posted sometime later. So yeah, we'll try and fix this. So now we get
There.
thank